Hello everyone. In this video I am going to demonstrate metal detector with audio and visual indicator. As you can see, this is my setup. Here is the measuring coil, sensing coil. So the presence of metal will be detected by this sensing coil and this capacitor. This capacitor is connected in parallel to this coil. I will show the circuit diagram and the connections will be very clear. So in this parallel LC circuit, I am using this transformer as well, that is measuring the current in the circuit. The current in the circuit is measured by this transformer and it is converted into voltage. The secondary of this transformer gives us the voltage reading and that is analyzed by the comparators, and we are deciding the metal presence. So as you can see here, this is the coil and here is the capacitor. So this parallel LC circuit is driven by this oscillator. You can see here this 555 oscillator. This oscillator is oscillating at a frequency of 52 kilohertz. The output of this oscillator is fed to this parallel LC circuit. I will show you the circuit diagram and that will be very clear after the circuit diagram. So whenever we bring metal in contact to this coil or in the close vicinity of this coil, the voltage across this circuit will change. That means this circuit is actually tuned. This circuit is actually tuned into resonance. So whenever there is a metal presence, the resonance will shift and the current flow in the circuit will change. So this change of current flow will be detected by this transformer, and the secondary of this transformer is analyzed by this comparator circuit. So let us look into the circuit diagram first, then I will show the performance of this circuit. So as you can see, this is the circuit diagram. You can see here this is the coil. I am using induction heater coil, one old induction heater, faulty induction heater coil I am using, and this 0.47 microfarad capacitor is connected in parallel to this coil. So basically this is forming a parallel LC circuit. And as you can see here, I am using 555 timer oscillator oscillating at a frequency of 52 kilohertz. I am supplying this circuit with a plus 5 volts DC supply. The output of this oscillator is fed to this parallel LC circuit. You can see the output of this oscillator is fed to this parallel LC circuit, and other end of the oscillator is pulled up to the plus 5 volts DC bus. So this is a pull up here, and in series I am using this transformer. So this transformer is responsible for detecting the current in the circuit. So the current is converted to voltage and we are converting this voltage because this is a high frequency voltage at a high frequency signal at a frequency of 52 kilohertz. So we need to convert this signal to DC signal. So without that, our comparators will not be able to decide the signal status. So I am converting this signal to a DC signal. You can see this is just a rectifier unit. So after the conversion of this signal to a DC signal, I am feeding it to a comparator. I am having a reference voltage here. So whenever the metal presence is there, there will be a change of current in this circuit and there will be change of voltage here. And this change of voltage is sensed by this comparator with this reference voltage. And finally we are giving a command to this 555 timer IC. You can see this is a 400 kilohertz audio tone generator circuit. So whenever there is a metal presence, this voltage will be 1 and it will give a signal here, and we will be able to see some sound on the speaker. You can see the output of this comparator is fed to this pin number 4 of 555 timer IC. So whenever we are controlling the 555 timer IC, whenever there is a metal presence, there will be a logic 1 and 0 and we will be able to hear the sound at this point. You can see here whenever there is no object on the coil, the voltage at the transformer secondary is 2.0 volts, 2 volts. The voltage at this point is 2 volts. You can see here the voltage is 2 volts. Again I will repeat, the voltage here is 2 volts. So here the voltage is 2.5 volts. So whenever there is a metal presence, this voltage will shoot up. It will become more than 2.5 volts and this logic will be 1 and it will trigger the audio amplifier. It will trigger the tone generator. It will trigger the tone generator. So now let us put some metal piece and we will see the voltage at this point. We will see the voltage at this point. I am putting one steel vessel. Let us see. The voltage is 2.8 volts. you can see the voltage was 2.8 volts. So voltage at this point voltage was 2.8 volts. So now I am going to put aluminum. We will see the voltage and the response of this circuit. I have put aluminum. See, it is how much? 3.1 volts. So the voltage at this point is 3.1 volts for aluminum. Let us write it down. 3.1 aluminum. So for aluminum it was 3.1 volts. For steel, how much it was? 2.7, 2.8. Say 2.7 volts for steel. So now I am going to put a bronze vessel. We will see the response. How much is the voltage? So here is the bronze. The voltage is again 3.5 volts. You can see highest. The voltage was 3.5 volts for bronze. So let me write it. 3.5 volts for bronze. So I have tested with 3 different metals. For steel, the voltage at this point was 2.7 volts. For aluminum, it was 3.1 volts. For bronze, it was 3.5 volts. So whenever there is a metal presence, the current is changing in the circuit and this voltage is changing. It became 2.7 volts for steel, 3.1 volt for aluminum, 3.5 volt for bronze. So I was having these 3 metals in my home. So I used with these 3 metals and the metal detector was working fine. You can see. So this is the circuit diagram and you have seen the performance of this circuit. So once again I would like to show the far view of the circuit. You can see. So this is the metal detector I have just tested. Thanks a lot. Thanks for watching.